Hi everyone, CES 2026. I'm with Jeff Yurek in Nanosys, where he's got some interesting stuff we want to talk about. Okay, let's talk about your the QD roadmap and some of the applications that you're working on.
Quantum dots have been commercialized in display since 2013, actually. So they've been in the market for a long time. So I wanted to talk a little bit about where quantum dots are going from here. And if you look at the top section of this chart, you can see quantum dots have actually a really great roadmap ahead in terms of improvements on the display side. And we'll talk about that first. So the top row is QDEF. This was the first component that was really commercialized by us for displays. And QDEF is still going strong. There's a lot of improvements. The super quantum dots we just mentioned are an example of how QDEF is continuing to improve over time. A couple of years ago, we also launched a QD Diffuser Plate, or QDP. This uses air-stable quantum dots in a lower cost component. Has less layers, it's a simple extruded component. One of the challenges for QDP was that you couldn't use it in very high brightness sets, right? It's very reliable, but you couldn't push it into the more premium sets. And so this year we're launching a new version of QDP that can do BT 2020 colors and very high brightness now. So we're really excited about that. The next thing on the roadmap for QDP is going to a fully heavy metal-free version of the quantum dot diffuser plate. We expect to achieve that in 2028. So a bit more work to do on that.
Oh, so those are not indium. They're not indium based.
Not today.
Okay, the cadmium base. Okay,
Yeah.
Gotcha.
Also this year, we're launching a new version of QDCC, that's quantum dot color conversion. These are the inks that are used in things like QD-OLED type of products. We have a new version of that material this year that we're able to collaborate on with an ink maker to improve the brightness of the material and the performance of the QDCC material. So you're seeing some new QD-OLED TVs this year with much higher brightness, and that's part of the story.
Okay.
We say medium flux because by 2030 we want to ship what we consider truly high flux. Now we're talking about not just a sort of a QD-OLED, but maybe a micro LED for something like an AR application, which would require hundreds of thousands or maybe 1 million or more nits. So truly high flux color conversion.
Yes, that's been a goal for many years. So, and I can see it's still many years away.
It's still many years away. And last, and perhaps the most interest to people, is QDEL. And we think 2029 is a reasonable target for when we'll start to see those in the market. That's QD electroluminescent displays.
In kind of medium flux levels?
Yeah, I think we're not sure what the product is going to be yet. Yeah,
okay.
Exactly. But yeah, don't expect those to be in the million nit class range. Yeah, for sure. We're also talking about some other applications that we could be getting to see become useful for quantum dots in optics, such as ultra-high refractive index materials to kind of shape light in interesting ways. Another one is a broad category we're calling sun power. It's a great startup called Ubiquity that's already commercialized copper indium sulfide quantum dots in agriculture applications. Think about something very similar to a QDEF that's actually converting sunlight, shaping sunlight in a greenhouse to be more effective for plant growth. You can buy this and put this in your greenhouse today, and they show really amazing results improving the yield, the crop yield, using these products. Next step for that technology we see coming is embedding it into solar panels as well.
Sure.
That's something they've talked about too. Also, pigments is a new area. There's some interesting work going on there, and actually here at the show we have the world's first 3D printer filament with quantum dots embedded inside. A startup here called Quantum Light. And that product's going to be available in March. So if you're interested in 3D printing and you want to print an object that has quantum dots in it, it has a very unique color property, you'll actually be able to buy that online and do that.
Yes.
And there's a whole roadmap of new kinds of pigment products that they're creating. Plastics and even automotive coatings are coming in the future.
Oh, that's fascinating. Yeah, you've got a demo over here of a motorcycle helmet.
That's right.
With it changes to a red pigment when you illuminate it.
Exactly. So when you're in the sunlight, it's more reddish, has a reddish glow, but then at night it's more black colored. So
Yeah.
kind of very interesting, very different from display. And we've been learning a lot about these new markets.
It is.
And then the last area is sensors and sensing, where quantum dots can add some value as well. We see commercial sensors, and then automotive is an interesting application there as well.
Gotcha.
Longer term.
Okay.